So let's start to debrief what you guys have come up with. How would we outline a completely randomized design to compare the two treatments? First of all, what are the two treatments? Let me stop there.
An online SAT prep class and an in-person.
Online and in-person teacher-led SAT prep courses. What were you going to say, Josh? Okay, got it. So what do we want to start off by doing in order to create our randomized design? Yes, sir.
Just randomly select the students.
How many?
50 students.
Well, we're starting with 50 students.
25.
Yes. So we're going to start with our 50 students. We're going to randomly assign them into two groups. Group 1, Group 2, each one roughly equivalent. We got lucky this time. It was an even number and we wanted to split it into two groups. If it's not an even number and we want to split it into two groups, one group will have one more than the other. That's okay. As long as we get them roughly equivalent here, we're all right. What do we do after we split them into our two groups here? Yes. And for a completely randomized design, you might want to do maybe a coin flip to decide whether group 1 is going to be the online or the teacher-led. But you want to randomly pick that out ahead of time. You don't want to wait until you get your two groups, look over those lists and go, okay, this is my online group and this is my teacher-led group. We want this to be as random as possible. So you're going to assign them to their two different treatments. They go through their prep courses, and then what? Compare the SAT scores, yes. So this is a completely randomized design. Nice work. So when you read through number 2, the counselors have this hypothesis that grade level is also really affecting our SAT scores. So if grade level is really affecting this, and when we split them up into the two groups randomly, we end up with like 15 seniors in this group and only 5 seniors in that group. Could that potentially confound our results so that we're not seeing a clear, was it the online course, was it the teacher course, which one's better? How could we control for that? What could we do? We want to adjust our experiment to ensure that there's an even split of juniors and seniors in each of these classes. Yes, ma'am.
So I did the whole thing in a different way. I added in a third group that didn't take the class at all.
Okay.
And so for seniors, I had, like, they would pick a number out of a hat, and 10 of them would take it online, and then 10 would take it in the classroom, and then I had, like, another 10 who would be randomly selected from the senior population that didn't take the class.
Okay.
And we use their scores. And then from the junior group, I had it selected from all 30 juniors, 10 took it online, 10 took in person, and then 10 from the volunteer group didn't take it at all.
I like it. I like it. I like it. So I only did 2 groups, but I like your 3-group setup where you're comparing online, teacher-led, and no prep course. That's absolutely a valid way to design a randomized experiment here. So you said you took your 50 students and the first thing you did was split them into the juniors and seniors and then assign them from there. Absolutely. So since I was only looking at the 2 treatments, just the online versus teacher-led, Jenna said she added in that 3rd group, so she pulled 10 more seniors from the student population here. These are, by the way, these are called blocks. It feels a lot like stratified, but when we're conducting an experiment versus a sample, we call them blocks. Feels a lot like strata, but it's not strata. We take each of our blocks. We use random assignment to get them into their groups. So I called them 1S and 2S for my seniors, 1J and 2J for my juniors. So I've got 10 seniors in each group. Ooh, for my juniors it should be 15, not 10, sorry. That's what I get for writing my numbers down wrong. So it should be 15 in each of those groups. Again, for the way I designed it. If you had 3 cases, then you'd set it up a little bit differently. Random assignment from there. Half of them are going to take the online prep course. Half of them are going to take the teacher-led. You randomly decide which group gets which case. What would you do after they've taken the course? We're going to compare the results. We're going to first compare the results just within a single block. So I'm going to start with comparing the results of my seniors, comparing the results of my juniors, and then I'm going to compare the results overall. So I'd compare these guys. So I want to compare within a block and between the blocks. This is what is called a randomized block design. Or it also just gets called block design. The reason that we use block design is that we're trying to control for a confounding variable here. If you have a hunch that your explanatory variable isn't the only thing that's affecting this, it's not just online versus teacher-led, you're like, I think grade also is strongly influencing this, that would be a confounding variable then, and the way you can control for that, which reduces variability in your results, is to block them this way. Again, feels a lot like the stratified sampling design, but we call them blocks, not strata, when we do it this way. What about this third one down here? It says the counselors are now worried that a student's GPA is certainly going to affect their SAT score. If we narrow it down to just the juniors, how could we try to control for GPA score? Does anybody have any thoughts?
How can we control the GPA score?
We can't control their GPA score, but I'm pretty sure that if somebody has a high GPA and I compare that to a student with a lower GPA, chances are, just out of experience, I'm guessing that the person with the higher GPA probably on average is going to do better on the SAT regardless of which class they take, right?
Yeah.
Jenna?
I would split them into 2 groups of 15 based on like high or low GPA. And then, like with mine, with the 3 options, 5 people would be randomly assigned to each group between that high and low, so there's an even spread.
That is definitely one way of doing it. I like it. Yes, sir.
One way I was thinking was like finding the average of 2 different groups of their GPAs. So like one group, you could put it in and then have them be a certain GPA overall, and another group put that in GPA like and separate, like one's higher and one's lower.
I like it. I like it. I like it. This is one that you might not have had much experience with. When we're really concerned and like ranking is playing out here, there's something that we can do called a matched pairs design. And it's basically where we have blocks that are only of size 2. So one of the ways that we could try to control for GPA scores is if I take the top 2 juniors that are in my volunteer pool, top 2 GPAs, and I match them together. So I put them in order from highest to lowest. I take my 2 students with the highest GPAs and I'm going to pair them. And then I randomly assign one of these guys to take the online course and the other one to take the teacher-led course. Flip a coin to decide who gets which one. And then I do that with the next 2 highest GPAs. And I repeat this until all 30 juniors are assigned. How many pair groups would I have?
15.
I would have 15 pair groups where one person in each pair that has similar GPAs, one person would get the online class, one person would get the teacher-led class, selected at random for each pair. Again, this is called a matched pairs design. It's a special type of block design. Just like block design, but each block is only of size 2. And again, we're going to use designs like this to try to control for confounding variables. We could use a matched pairs design and an overall block design. I could take all of my seniors and pair them up. I could take all of my juniors and pair them up so that I've got these 2 big blocks, and inside of each of those I've got all these little blocks set up. Experimental designs can get really complicated. The more confounding variables that you think might be going on, the more ways we're going to try to control for some of those confounding variables. So when we're thinking about doing block design or even matched pairs design, the variable that you want to be using here to determine your blocks or to determine your pairs is the one that you think is having the biggest outside influence other than just your explanatory variable that you're trying to test. So randomized design, we've talked about that particular structure quite a bit. We've added 2 other design types today, block design and matched pairs design. As soon as I know everybody's gotten this copied down, we'll flip it over and we'll copy down our big ideas for today in summarized form. Yes, sir?
Can you explain the block again?
Yeah. So in blocking, when we use a block design, we're going to take, it feels like stratified sampling, right? So if the counselors are like, man, just seeing these scores roll in year after year, our seniors seem to be more motivated or they've had more experience with just testing in general. Our senior scores tend to be higher than our juniors. So if I'm trying to figure out which of these classes is most effective, it would be better if I could split my juniors into 2 groups and take my seniors and split them into 2 groups. So then I'm taking out well, maybe they just did better because this group has more seniors in it than juniors. Does that make sense? Yeah. So what we're trying to do is tease apart how much of it is the classes, which is what we're actually testing, and how much of it could be coming from just age differences. When we do that block design, we can control for that. Does that make sense?
Yeah.
Okay. Yeah. Yeah, that's exactly right. All right. Our blocks are going to be a group of experimental units that are all similar to each other. So when we set up the blocks on this one, we have a block of seniors and a block of juniors. Or sometimes you'll see experiments where they think gender could be a confounding variable. So you'd have a block of males, a block of females, and maybe a block of people that don't identify as either male or female. You are not restricted to just 2 blocks. You will set up blocks based on however many categories there are in that confounding variable. For your randomized block design, you separate your subjects into the blocks and then you randomly assign them to the treatments within each block. In this case, I was only looking at 2 treatments. When Jenna talked about hers, she was talking about 3 treatments. Perfectly fine. However many treatments you have, that's how many groups you would split each of your blocks into. For your matched pairs design, the subjects are going to be paired. And then you will randomly assign them to a treatment. Ideally, each person in a matched pairs design would get both of the treatments separately, and you test them under both conditions. And the order that they receive those treatments in has got to be randomized. As soon as people feel like they're starting to sense a pattern, that absolutely influences the results that you have. Once you get the big ideas copied down, go ahead and try the check for understanding. Describe a completely randomized design. Describe a block design. Make sure you justify why you made the selection of the blocks that you did. Why was that the variable that you chose? And why might a randomized block design be a really good idea in this context? About 2 more minutes, and then we're going to compare your thoughts versus mine.
Already bid. So every 3.
Oh, like where you don't have to watch them all the way through, like you're like after 3 seconds. Yeah, you could, like once your 300 random users are picked out, you could have somebody dig through their user data, see who are the people that are more likely to skip versus who are the people that are more likely to watch the ad. That would be something that you could do with blocks, absolutely.
There's only 3 groups in there.
How are we feeling about an overall randomized design? How many treatments are we looking at here? 3 treatments. What are the 3 treatments?
We don't know. YouTube advertising.
Yeah, we've got 3 different advertisements. So we've got 300 randomly selected users. What do we want to do to come up with our completely randomized design?
I split them into 3 groups. One group only sees ads for like the Republican candidate. The other group only sees ads for a Democratic candidate. And the other group, or the last group, sees ads for both of them.
That could work. So 300 subjects, we need to get them randomly assigned. Please don't forget to include this piece in your design model. Whether you state exactly how you would do it, I would use a random number generator, I would pull names from a hat, I would whatever. You do need to clearly state that you're going to use random assignment. So if that is not something that you've been including in your mapping, you need to make sure to include that in your mapping. And then we've got them split into 3 groups, 100 in each group. I didn't get quite as specific as you did on yours. I just said, we've got our 3 ads, ad 1, 2, and 3. Randomly assign these 3 groups to those 3 ads. Then bring it back together and compare the effectiveness of that. All right. For the block design, we've got to start off with our block design of thinking about what is a potentially confounding variable here, other than just the advertisements. Our advertisements are our explanatory variable. This is what we're trying to use to predict our response variable. There might be something more going on under the surface, and we want to try to control for that. What are some thoughts about potentially confounding variables here? Age. Anything else? Yes, ma'am.
The political party that the users are part of.
Political party affiliation. Maybe they're a registered Democrat or a registered Republican, or some states even allow for registered independent voters. That would be something that you might want to consider. Yes, ma'am.
If the ad is skippable.
If the ad is skippable, Raul.
Experience.
Experience, yes. Maybe they're quite old, but they haven't actually voted that often. So that would be something to consider. Or how experienced they are as far as YouTube goes in general. You could look at how long they've been a part of YouTube or how long they've been using YouTube. Yes, ma'am.
We could make sure to exclude people who are under 18 or not registered to vote, because then you're actually getting the voting population, not just.
Absolutely. So maybe as we pull these 300 random YouTube users, making sure to exclude anybody that's not of voting age or won't be by the time of the election. Absolutely. So when I set mine up to use for example purposes, I used age, younger and older. Remember, we want our groups to be roughly equivalent, but any of the other things that were mentioned could be used as blocks. Registered political party affiliation could be used. Maybe you chose gender. Maybe higher education, people that only have a high school diploma versus people that have a college degree. You might use those for your blocks. These are all things that in the past have been identified as, like, when we split up and look at these two groups within this single block, it does seem to have an effect. So we'd use random assignment then to assign them to the 3 add groups. No matter how many blocks you choose to break it into, each block then has to receive those 3 treatments.
That's exactly what I did.
We would compare the effectiveness within a block, and then we'd compare our overall effectiveness. I'm going to pop this up higher on the screen. All right. Why could a randomized block design be preferable in this context, no matter what variable you use to decide on your blocks?
Why would it be preferable?
Why would it maybe be a good idea to do a block design on something like this?
Because 300 people is a lot, so making it smaller, make it easier.
That could definitely help. Grayson, did you have a thought?
I also thought that it could be like really skewed if you have it all in one bunch because there's a lot of different opinions.
Yeah, absolutely. I think it could end up. So remember, the whole goal for us doing block design, much like when we choose stratified, we're looking for things that reduce our variability here. We're trying to see, of these 3 adds, which one is the most effective. And if age is skewing those results, if I have one group that has more older people than younger people, I might only be seeing which ad is most effective with the older group, not which ad is most effective overall. So in my particular design, it helped to control for age as a confounding variable. Within each block, there's going to be lower variability of results, making it easier for me to determine which ad is the overall most effective. And before we go, I don't want to interrupt you guys getting this written down, but I do need to ask for some math department help from you guys. I'm going to ask you to evaluate. I've got some resumes from a couple different individuals that have applied for jobs here at Pike. So since you guys are the consumers of education, I'm very interested in your thoughts and your feedback on this. These are like going to be fresh out of college. They have not yet graduated. Teacher applicants. To protect your privacy, don't put your name on these at all. I just want you to evaluate how likely you would be to hire the applicant for a math teaching position based on their resume. It's just the front side, and then your evaluation of how likely you would be to hire them is on the back. You'll just circle a single number for me. So I'm going to pass these out to you guys. Look over their resume, see what you think. Would you recommend them to be hired? All right? And if I could get these back from you guys before you leave the room, that would be super, super helpful. So it's just a 1 to 7 scale. If you would not hire them, give them a 1. If you would hire them, give them a 7. If you're somewhere in between, give them something in between. And then just pop it in the empty basket on your way out the door for me.
They like to do my
Yeah, look over their resume. What do you think about hiring them here at Pike?
This is all one.
Give them, yeah, it's just one person, it's just the front side. And on the back, you'll give your rating. Yep.
How did you grade them?
How did I grade them?
How did you doing your shit?
Hmm?
They did that themselves?
Yes.
Oh.
That is their own ratings of their skills. Yep, I did not make these. So again, before you leave, if you could give me a rating on a scale of 1 to 7, how likely would you be to hire them? Pop it on the test side. Right now it's currently empty. Before you walk out the door, just want to get some feedback from students.
Is this real? Or is this for
Of course it's
tomorrow?
real.